Welcome to this predicted paper from onmaths that is based on the advanced information given to us by the exam boards. Please use this paper in addition to your other revision. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing. Multiples are times tables, so the multiples of 2 are the times table of 2. So 2, 4, 6, 8, 10, 12, etc, etc. So the only number in this list that is in the 2 times table is the 6. So we're just going to start by writing the number a little bit bigger. So it says to 2 decimal places, so we're going to draw a line after the second decimal place. Now all the numbers to the right are going to disappear. They're going to turn to 0, and because it's a decimal, that just means we get rid of them. But we have to look at this number first. Now if this number is less than 5, we just keep the number to the left, so 8.17. But if it's 5 or more, then this 7 goes up to an 8. So this will be 8.18. In this question, we're given the output as 53. So we know that the output was 53. So now we've kind of got to work backwards. And when we work backwards through a function machine or a number machine, we do the opposite of what it says. So this first one says plus 9, but when we go backwards, we do the opposite, which is take away 9. So we do 53 take away 9, which is 44. Now we can check that by going the other way, so 44 plus 9 is 53, so that works. The next one says times 4, so the opposite would be divided by 4. So we're going to do 44 divided by 4, and that gives us an input of 11. Now let's check the whole thing. We put in 11, 11 times 4 is 44, 44 plus 9 is 53, so we know we've got it correct. If we tried to draw a quadrilateral with a pair of parallel sides, and then it's a quadrilateral, so join them up, it's got 4 sides, then the shape we draw will always be a trapezium. So our answer is that it is a trapezium. Now you might think that a rectangle and square does have one pair of parallel sides, but it actually has 2 pairs of parallel sides. The definition of a trapezium is it has just one pair of parallel sides, and any quadrilateral that has one pair of parallel sides is a trapezium. To find a coordinate, what we can do is we can start in the middle and we work out how far across we have to go. And here we have to go 2 across, so the x coordinate is 2. Then we find out how far upwards or downwards we have to go. And here we can go, well, we have to go 3 downwards, so that's going to be minus 3. So we first of all look at the x coordinate, the 2, then the y coordinate, minus 3, along the corridor, up, or in this case down the stairs. First thing I'm going to do to answer this question is I'm just going to quickly draw out the shape again, just so I can kind of show the calculations a bit easier. Okay, the first thing I'm going to do on the diagram is convert all of these lengths to centimetres. So we've got 4,200, 1,200, 2,400 and 1,800. And next I'm going to convert them into what the scale says they're going to be in our diagram. So a scale of 1 to 600 means 600 in real life, and this diagram is showing the real life situation, is 1 on our diagram. So I've converted them all in centimetres, and now I need to work out how many centimetres there are going to be on our diagram. So I'm going to start with the 4,200, and all you need to do is divide it by 600, and I get the answer of 7. So it's going to be 7 centimetres on our diagram. 1,200 divided by 600, it's going to be 2. So that's going to be 2 centimetres on our diagram. 2,400 is obviously going to be 4 centimetres. And 1,800, divide that by the 600, it's obviously going to be 3. So it's going to be 3 centimeters. So now we know what it's going to be on our diagram. We draw it. So we're going to do 7 across. So 1, 2, 3, 4, 5, 6, 7 across there. I'm going to do 2 down. So 1, 2, 4 across. 1, 2, 3, 4. I'm going to do the left hand one first, I think. So we're going to do 3 down here. And then we just kind of join it up with what's left over. And that's our diagram. So firstly, we're going to work out what the percentage increases are as a multiplier. So we start off with 100%. Jane has a 1.2% interest pay rise, sorry, and so that would be 101.2%, and we divide that by 100 to make it a multiplier. So the multiplier is 1.012. So we get the 20,000 times it by 1.012, and that gives us 240. Next we do the same for Lenny, so that is Jane. And so let's do Lenny. And so that's 100% plus the 1.5% will be 101.5%. Make that a multiplier, 101.5%. We divide that by 100, which gives us 1.015. And then finally what we do is we get the 17,000 times it by the multiplier. And when we do that, we get 255. So Lenny has 255, Jane has 240. So it says which of the employees has a larger pay increase and by how much. So the answer will be Lenny, and it's by £15 because that's the difference between these. We've got to first of all find out what the y-intercept is, and the y-intercept is just where our line hits the y-axis. So the y-intercept, which we sometimes can call C, is 11. Now, what's that 11? What units is it? Well, it's 11 pounds because our y coordinate, our y-axis is in pounds. But what does that mean for the taxi company? Well, how many miles have been travelled on the y-axis? Well, 0. So at 0 miles, we've had to pay the taxi man or woman £11. So we know that therefore the taxi costs £11 at the start. We'll just leave it at that. Okay, so the initial charge, or the cost for the taxi turning up, is £11. So you do need to know the parts of a circle. So the full distance around the circle is called the circumference. If you've got a little bit of it, it's an arc. If you've got a line across it, that would be a chord. And the part that's kind of trapped in there is called a segment. Then if you've got a line across the circle going through the centre, that's a diameter. If you've got a line just going to the centre, if I can draw it properly, then that's called a radius. If you've got a line that touches the circle just on one point, like that, that's a tangent. But in this case, we have a sector. So we're going to track the amount of eggs to make the amount of, or to make each amount of omelette. So 5 eggs makes 17 omelettes. And we're just going to find out how much is required, how many eggs is required to make 1 omelette. So we divide that by 17, divide both sides by 17. And so 1 omelette would be 0.294 blah 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 eggs. Next we want to see how many for 67 omelettes. And to get to 67 from 1 times 67, So do that to the amount of eggs, and we get 19.705, blah blah blah. Now you can't get 0.705 of an egg. We always round with eggs, and we always round upwards, because if you need 19.7, 19 won't be enough, so we need to pick 20 eggs. The median is the middle number when the numbers are in order. Now it's quite difficult to do with a table, so we used a formula, and that formula is to find the position of the median. We do how many numbers there are, which I'll call n, we add 1 to it, and then we divide that by 2. And that shows us where the median is. It doesn't tell us what the median is, it shows us where it is. Now, we need to figure out where these numbers are in this list. So the first number is a 2, and there is one of those. The next number is a 3, and there's 3 of those. So 1, 2, 3. The next number is a 4, and there's 4 of those. So 1, 2, 3, 4. The next number is a 5, and there's 8 of those. So 1, 2, 3, 4, 5, 6, 7, 8. And the next number is a 6, and there's 13 of those. Now I'm not going to do all of them, okay, because we're not going to be working out the median by writing out all the numbers, but I do want to show you where these numbers are coming from. So what we do is we do a running total. So I'm going to do a running total. The running total is just adding up the frequencies as we go. So the first one is just 1. Then we're going to add the 3 in the next row, so that's 4. Add the 4 in the next row, 8. Add the 8 in the next row, 16. Add the 13 in the next row, and that would be 29. Now, we use the running total because the running total shows us where the last number is in that group. Okay, so this shows us that the first number is the last number that is a 2, which is true, we can see it here. This 4 shows us that the fourth number is the last number that's a 3, so let's check that. 1, 2, 3, 4, it works. This 8 shows us the 8th number is the last number that's a 4, let's check that. So 4, 5, 6, 7, 8. This 16 shows us the 16th number is the last number that's a 5. So 9, 10, 11, 12, 13, 14, 15, 16. And this 29 here shows us that the 29th number is just the last number, but it's the last number that's the 6th. Okay, so let's work out how many numbers there are, and we do that by adding up the frequency. So we're just going to add up all of the frequency together, and we find out that there's 29 numbers altogether. So 1 plus 3 plus 4 plus 8 plus 13. So using our formula, which is 29 plus 1 divided by 2. 29 plus 1 is 30, divided by 2 is 15. So we're looking for the 15th number. So looking down our running total list, well, the last number that's a 4 is the 8th number, so we haven't got to the 15th number yet. And the last number that's a 5 is the 16th number. So if the last number that's a 5 is the 16th number, then surely the 15th must also be a 5. And so our median is 5. So we're going to start off by filling out this table. So 0 times 1, 0 times 2, 0 times 3, 1 times those, 2 times those, and 3 times those. And we're looking for the probability that the product, which just means that when we times them together, will be more than 2. So which of these are more than 2? Let's circle all the ones that are more than 2. And to work out a probability, it's always the successful outcomes over the total amount. So the successful ones are the ones I've circled, so 1, 2, 3, 4, 5, 6, 7, 8, 9. The total are all of them together, where it's a 4x4 grid, so it'd be 16 in total. And so the probability that the product will be more than 2 will be 9 over 16. To answer this question, we need to know what an equation, expression, formula, and identity is. So the formula is basically an equation but for real world things. So area equals pi r squared. It's where the letters actually mean something. Expression is just algebra without the equal sign. So 5x plus 3 would be an expression. An equation has an equals and it can be solved. So you can find out what x is or find out what a is. And an identity is true for all values of that letter. So an example would be x times x equals x squared. That's an identity because that's true for all values of x. So looking here on the right hand side, we've got 3x plus 2x. But if we imagine x is 10, so 3x would be 30 plus 2x would be 20, 30 plus 20, well that will equal 5x, 5 times 10. And actually this is true for all values of x. And the reason it's true for all values of x is we know that 3x plus 2x, this right hand side here, equals 5x. They're the same thing. Now normally with an identity, it's shown with 3 lines. Now in the exam, this type of question, it won't be shown with 3 lines because that kind of gives it away that it's an identity. But this question is definitely an identity. And you can't solve it because it's true for all values of x. So yes, x could be 10, x could be 1,000,000, x could be 1/3, x could be anything. I'm just going to write the question out so we've got a little bit bigger writing to play with here. And it doesn't actually matter which method you expand these brackets with. I'm going to use Smiles and Rainbows. So we multiply the 8 by the 10x, which will make 80x, and multiply the 8 by the 4, which will make 32. Now here we've got a minus 5 on the outside. So we do minus 5 times 8x, which is minus 40x, and minus 5 times minus 4, which is actually plus 20. And a lot of students will write take away 20 there, but that is a minus 5 on the outside of the brackets there. So it's minus 5 times the minus 4 there will give you a plus 20. Then 80x take away 40x, which will give us 40x. And 32 plus 20, which would be 52. So our answer would be 40x plus 52. So this question says that Adrian, Ben and Charlie have some sweets and the ratio of Adrian to Ben to Charlie is 9 to 6 to 13. But it also says that Charlie got 56 more sweets than Adrian. So there's 56 more sweets. Well, looking at the actual parts of the ratio, there are 4 more parts. So plus 4 parts, which represent plus 56 sweets. So the 4 extra parts are worth 56 sweets. So 4 parts are worth 56 sweets. So 1 part would be 56 divided by 4, which is 14 sweets. So all we need to do now is work out how many parts there are. Well, there are 9 plus 6 plus 13 parts, which is 28. And each part is worth 14 sweets. So the total number of sweets will be 28 times 14. So 28 times 14 is 392. So we know that James knows that he has a square. So we can actually get rid of all of this bit. It's not relevant at all to the question. And the question asks, what is the probability that the square is blue? Well, there are 3 blue squares, so it will be 3 over, and how many are there in total? Well, it says the total is 17. So the answer is 3 over 17. When you multiply powers with the same base, you add the powers. So we're going to do that here. We're going to add the 13 and the 4 at the top of this fraction. 13 plus 4 is 17, so it's going to be 5, to the power of 17. We haven't done anything with the 5 to the power of 5 at the bottom yet. When you divide powers of the same base, you subtract the powers. So we're going to do 17 take away 5, so it's going to be 5 to the power of 12. So we're going to first of all convert the 11 litres into millilitres. So we're going to do 11 times 1,000, which would be 11,000. Okay, so we're going to just draw a line, like a number line. And we're going to have the 11,000 in the middle. Now, what would be the next one down if we're looking at to the nearest 10 mil? So we're going to add a 10 mil on, which will be 11,010, and we're going to take the 10 mil away. So 11,000 take away 10 mil will be 10. What is it? 990. Now, when we're looking at limits with the upper and lower part of it, we are looking at halfway points. So halfway here and halfway here. So this halfway point will be 10,995, and the next one will be 11,005, and that's the halfway points. And so that is going to be our upper and lower bound. And we just need to say that V can be anything above the 10,995 and including that, and it can be anything below 11,005, but it can't include that, because if it did, if it was 11,005, it would have rounded up to 11,010. So we're going to start off with 100%, and it says that the card depreciates. That means goes down by, so it goes down by 1.7% every year. So we do 100 take away 1.7, which is 98.3, and that's percent. And we want that as a decimal, or as a multiplier we call it. And so we just divide it by 100 to make it into a decimal, 0.983. And that's our multiplier. And the beautiful thing about a multiplier is we just need the amount of years. Well, it says from 1980 to 1985. So that's going to be 5 years. So it's going to be 5 years. And so what we do is we get the original amount, which was 2,245, and times it by the multiplier 5 times. Now, I can't be bothered on my calculator to times it by 0.983 5 times. So what you can do is you can do it to the power of 5, which basically means the same thing. And that gives us 2060.553. And when we round that, that would be £2,060 and 55 pence. So we need to first of all work out what the length of the side of the square is. And to do that, what we do is we get the 44v to the power of 4, w to the power of 5, and we just divide it by 4. And to do that, all we need to do is just divide the coefficient by 4. So it'd be 11v to the power of 4, w to the power of 5. Some people will try and do something with the v to the power of 4, w to the power of 5. But if you think about it, if I just draw out my square, if it's 11v to the power of 4, w to the power of 5 all the way around, when you add, you don't add the v to the power of 4, w to the power of 5. It's just going to be 11 lots, another 11 lot, another lot of 11, and another lot of 11. So it's 44 v to the power of 4, w to the power of 5 in total. And to work out what the area is, we obviously are going to square that. So we're going to do 11 v to the power of 4, w to the power of 5, and we're going to just times it by itself, which is what squaring means. Okay, so we're going to times the 11s together, so that's going to be 121. Going to times the v to the power of 4s together, and remember with indices, if you times two powers of the same base, and they're both v, then we just add the powers together, so that'd be 8. And we're going to add the w to the power of 5s together, so that makes 10. So it's 121 v to the power of 8, w to the power of 10. You can complete a unique version of this paper by going to our onmaths site. onmaths is full of free content to help you prepare for your exams, such as topic-based papers, demon questions and mini mocks. If you like what we do, please consider subscribing.